Welcome to Frank Farrow Design and the first episode of my new series, Hardware Demystified. The goal of this series is to go through each part of a computer, talk about what every component does, and when you're looking at an ad, what parts you should care about and why for the work or games that you do. Today, we're going to start by talking about the processor. This is the brain of your computer that actually does all of the math that makes a computer compute. So what we're actually going to do today is go through an ad at Best Buy for a normal, pretty affordable desktop computer. And we're going to look at what it says about the processor it has. I'm going to go through what each one of those things means and whether or not it's something you should really target depending on what type of work you do. So the goal is by the end of this, if you suddenly had to build your own computer from parts, you would actually feel comfortable doing that, knowing what each part does. So today we start with the processor. Tomorrow, who knows? Let's get into it. So I went to bestbuy.com and looked up this computer. It's a desktop from HP. So as we go through and look at what it says it's HP. That's who actually makes the computer. It's a desktop because it's a desktop as opposed to a laptop. Then it says AMD Ryzen 5 series. That's actually the CPU. That's the processor that we're going to be talking about today. Then it mentions that it has 12 gigs of memory, which is what I think we're going to talk about next time. 256 gigs of solid state drive that we're going to talk about later, and that it's black, which, I hope you know what the fact that it's black means. So we'll talk about those things in later episodes, but for now we'll focus on the CPU. Then if we look down further in the general description, it gives you a little bit more information. In this case, all it tells you is about the 5 series class of processors from AMD in general, and that they have up to 6 cores, but it's up to, so not every 5 series processor has 6 cores. But it still gives you an idea of where you're at. Then as we go further down to the specifications, we get some more detail. We see that it has a base speed of 3.7 gigahertz, and the model number is the 3400G. So using that, we now have 4 main pieces of information you need to know about any given processor. You have the manufacturer, you have an idea of how many cores, which the model number can tell you exactly how many. You know the base speed, and we know the model number, which again can tell us things like the exact speed, how many cores, and things like if it has integrated graphics. Now let's dive into what each one of those 4 pieces of information means for you. So for the manufacturer, we know that this is an AMD chip. AMD and Intel are the 2 main manufacturers for processors. Intel is by far the industry leader. They have something like 75% or more of the market share in desktops and laptops, and I think even more for workstation and servers. But the thing to know right now is that also, especially for home PCs, AMD is pushing the boundaries a little bit more than Intel has been able to, and is really doing some interesting innovating, so they're actually starting to cut into Intel's lead. So right now, AMD makes slightly quicker and more efficient processors that also tend to have more cores and support faster memory. So it gives you, in some ways, a little bit better bang for the buck. Whereas Intel can give you higher raw speed And it's because it's such a bigger company, it's a little better tested, which for home use doesn't really matter a ton. But for uses like enterprise uses or in a server, Intel does seem to run a little more steady and might be the better way to go because it's a little bit safer of a bet. So, in short, this is a very hotly contested argument that I'm sure I might get comments about oversimplifying and whatever. But I would sum it up like this. If you're making a server or something that's very single core heavy, which again, I'll get into what that means later, you may want to look more towards Intel. But if you're doing something multi-core or you want just the best bang for the buck, then I would look towards AMD. So let's talk about that core count thing I've talked about a couple times. So you might remember back in the 90s, computers used to have a single processor chip. That was just the only way you could get them. Then slowly in the late 90s, for home computers, you started to see things that would occasionally have two processors in one. And it was kind of a big rare deal if you saw one, but it also wasn't super useful. Windows wasn't very good at handling it, and only certain software really knew how to harness both processors at once. So it was a really specialized niche market. But slowly, the processor manufacturers started to figure out that one of the ways they could make their processors faster was instead of making two chips go in your computer, they could actually put the processing part of the processor, they could put two of those on a single chip. So there were two processing cores on one chip. And Windows also got better at figuring out how to harness those two parallel processors so that you could do things like either run complicated math from two sides at the same time, essentially, or if you just happen to be both watching a video and also typing a Word document, it could actually split off the Word document in Windows working on one processor and the video working on the other processor to make your multitasking quicker. And that has grown and grown over time. So now AMD has some processors that have 4 or 6, 8, 12. They even have some really high-end processors that cost thousands of dollars each that have 64 cores on a single processor chip. So the thing to know, though, is not everything can take advantage of it super well still. Some, like games or drafting software or 3D modeling software, when you're actually doing the modeling, still can only use a single core at a time just because of how the software is designed and how it has to function. It can only do one part of math at once. Other software, like Photoshop, can take multiple angles at a thing at one time and give you more performance with multiple cores. Another thing to know about is something called simultaneous multi-threading. For Intel, they called it hyper-threading for a long time. And this allows each core to actually kind of multitask itself and kind of act like two cores. This doesn't have a 100% efficiency, though. So you might see, like for instance, in our 3400G, it says that this has 4 cores and 8 threads. But this is not the same as a processor with 8 cores. It's not that efficient, but it's certainly more efficient than a 4-core processor in terms of its ability to do things. So, as I mentioned, some software is really great at taking advantage of multiple cores. Photoshop sees benefits in all the way up to 8 cores. When you're exporting video from something like Adobe Premiere, DaVinci Resolve, you essentially can use an unlimited number of cores. But as I also mentioned, there's also certain programs that just can only ever use one core. But like I said, as our daily computer lives have become more intensive, that multitasking ability of having multiple cores has become more and more important. Because I know when I'm doing work on a deadline sometimes, I end up with Photoshop, InDesign, SketchUp, AutoCAD all open, but then I also am listening to music on Spotify and have a couple Chrome windows open because I'm trying to do research and find reference photos or whatever. So sometimes I end up using a bunch of pieces of software at the same time and jumping back and forth between them quickly, and even using two screens and having some on some screen and another on another screen. So the ability for those cores to kind of split off, do what they want to do, and Windows is good enough at that now that it can say, okay, you're doing a lot of Photoshop work right now. I'm going to pull those cores off onto their own section so they can do their best. And I'll kind of put your email and Windows backend and your Chrome windows you're not really looking at, those will move more towards the other side so you can really optimize your speed. So you can see the speed is given for your 3400G in gigahertz. That's the standard measure for speed in a processor nowadays. That actually means how many operations or calculations your computer processor can do each second in billions. So your 3.7 gigahertz processor can do 3.7 billion operations each second. Now, what the thing that makes that a little more complicated is that's your base clock. If you look, it can also list, if you look at more details for the processor, a boost clock. And in this case, the boost clock is 4.2 gigahertz. So what that means is if you have enough power and if everything's running cool enough, you can actually get your performance to increase and do more math at a given time, at least for a little bit. So you'll always, if you need it, be able to hit that 3.7 constant. But if you have enough power and cooling, you could hit 4.2 the whole time too and get even faster. But it's kind of a not guaranteed turbo boost kind of a thing. But it's something that's important to keep in mind when you're doing it. So Intel generally has the lead in that clock speed. They have some processors that can actually boost up to, I think the 11th generation, that as this video comes out, the 11th generation came out 2 days ago. At least a couple of those chips can boost up to potentially 5.3 gigahertz. AMD has never gotten a boost clock standard above 4.9. So AMD, in theory, single core can go faster. One thing that muddies the water a little bit is AMD actually makes each one of those operations slightly more efficiently. So that doesn't mean a 4.9 AMD is faster than a 5.3, but it does mean that if you have a 3.7 gigahertz AMD and a 3.8 gigahertz Intel, the Intel chip might not actually be faster. It's not apples and oranges, it's more like oranges and clementines. It's just a little bit different. It's something to keep in mind again when you're comparing manufacturers. But, you know, when it comes down to it, higher number, faster speed per core. So again, when you're doing single core processes, that's the number that's more important to you than core count. So the last thing you need to pay attention to is whether or not a processor has integrated graphics. That means that the processor can actually act as its own graphics card and output video for you to look at on your screen. Intel, by default, most of their processors have integrated graphics. For the 10th generation, only models with an F on the end didn't have integrated graphics, and basically it saved you 30 or 50 bucks, but there was no other real effect on it. For AMD, it's a little bit different. Those, you look for a G at the end of the model number. So like this 3400G. The effect that has is it might be a little cheaper, but the bigger thing is basically a couple of the cores that would have otherwise been on that chip as a 5 series chip are removed, and instead the graphics portion is put on. So the 3400G is in a lot of ways similar to AMD's 3600. The 3600 has 6 cores, whereas the 3400G has 4 cores, but also integrated graphics. Now, the integrated graphics are fine if you're doing Word documentation or even, light gaming. But if you want to do heavy-duty gaming, you kind of need a graphics card at this point, which is a whole different ball of wax that we'll get into several episodes down the road. But the thing to know is, too, just because you have integrated graphics doesn't mean you can't also mount a graphics card on there. If you connect a graphics card, generally the integrated graphics part just turns off and is ignored. It doesn't get you anything when that happens, but you don't lose anything per se either. So it's something that's there as a feature if you need it, but if you don't need it, don't worry about it. So we relatively quickly ran through the 4 key things you need to know about when you're looking at a processor. The manufacturer, AMD versus Intel, the core count, which is kind of how many things it can do at a time, the speed, how fast it can do those things, and the inclusion of integrated graphics if it needs help to be able to actually show you an image on the screen. Now you can get a little closer to looking at a computer ad and knowing that if you do Photoshop but no gaming, no video editing, and you don't do a ton of multitasking, getting 12 cores at a slightly lower speed than an 8-core processor might not only be throwing money away, but actually costing you because of that reduction in speed in those additional cores. We'll dive into the weeds on that a little bit more when I talk about profession-specific builds, which is something I'm going to be doing in a different series that I'll be starting soon. Remember, drop a comment down below if you want me to look at a profession you'd like to see a typical or ideal build for. And also, if you have any questions about processors that I didn't answer, send me comments. I will either do another video or I might do a Q&A video at some point. But before that, the next Hardware Demystified will be on memory. So make sure you subscribe so you get notified so that you know when that video goes live. And you'll be building your own PC before you know it. I'd also love it if you like, subscribe, share this video with friends, and I hope to see you next time. Be safe out there.